So when I said that computation of a limit when it exists is similar to what you're used to, what I didn't say was that when the limit doesn't exist, things are going to be a little bit different. And so I'm going to write out the steps we take to do this, and then we'll do an example afterwards. So if you want to show that a limit of f of xy does not exist, what you're going to do is you're going to pick a path for your limit. So you're trying to take some xy to x0, y0. And we'll see some examples of paths that you can take, but they can be like y equal to a constant times x, so y equal to 1x, y equal to 4x, so on and so forth. They can be y equal to powers of x, so y equal to x squared, y equal to x cubed, so on and so forth. And they can, actually I should write here, they can even be non-integer powers of x. So y equals square root x is just x to the power of half. That's okay too. Or, x equal to y sub p, x equal to my. Those are the same as what I already wrote, but sometimes it's easier to think about y being the thing with more powers or y being the thing that's a scalar multiple. Those are what I mean by paths. And then you're going to evaluate the limit by plugging in wherever you see y, replace it with the path. Or if you picked one of these bottom ones, x equal to the path. And then once you plug that in, that's just a limit of one variable, which you should be very familiar with taking, even if you don't particularly like it. Then you're going to repeat steps 1 and 2 for a different path. And then once you do that, you should be able to show that the number you got the first time is different from the number you got the second time. And kind of the argument is that if you could reach the limit 2 different ways and get 2 different answers, then it clearly doesn't exist. We can build intuition for that with like when you did limits the first time, you would have been like, oh, if I approach from the positive x-axis, I get positive infinity. From the negative x-axis, I get negative infinity. So those things don't match up. So this limit does not exist. We're doing the same thing, but now that x and y kind of live in 2 dimensions, it's not just approaching from 2 different directions. It's approaching along 2 different paths. These problems can get a little bit long, and I don't want to go over, so I'm going to stop here, and then I'll show you the example in the next video.